All right, we're into our second part of this numerical design problem. And on the first part, we selected a Y-flange steel shape. Now we're going to look at a channel. Channel, or sometimes called a C shape, because when you arrange the profile of the cross-section like this, it looks like a capital C, is sort of like 1/2 of a Y-flange shape. It's not 1/2. There's a variety of different differences there. The primary one being that this flange outer surface and the inner flange surface are not parallel to each other. The other part that is typically different is that this flange width is quite a bit smaller than compared to the depth of the cross section than you'd see in the typical W shape. So these, if you had two of these right back to each other, actually would look like a capital I, whereas the other ones sort of look like a capital H turned on its side. So we're going to take a look at this. This is very commonly used for a variety of applications of usually of a lighter type of load situation. But here, last time we talked about having a demand of 250 kip foot. When we go look at channels, they are produced in the A36 material. That is not as strong as the A992 grade 50. You might wonder what's going on there. And why is that the case? Well, historically, the Y-flange shapes were also made of A36 steel, and it was rare that you could get the higher strength, and you were charged quite a bit more for that. And then somewhere along in about the 1990s, that changed, and the steel manufacturers were willing to produce, and the demand was high enough for the higher grade strength steel for the W shapes, but that was not the case for the channels. So they still only make that in the A36, right? And it turns out with the ASTM designation A36, this number 36, just for this series happens to coincide with the yield stress 36 KSI. That's where it came from, but that's not generally the case. It just happens to be in this particular one. So you don't actually have to look it up. You just have to remember A36. Hey, that's 36 KSI. All right, so remember last time we went and found the allowable stress. That was our yield stress divided by the factor of safety. Because the yield stress has changed, then our allowable stress has also changed, and we're down to 24 KSI for our allowable. We find a geometric property that's required so that we have sufficient strength by looking at that elastic section modulus that's required. Remember that all came from that S is equal to I over C, sigma max equals MC over I or M over S, set the allowable stress equal to the maximum applied stress, and that's how we derive this particular expression. We got 250 kip foot that we convert into kip inches by multiplying by 12 inches per foot, divide by the allowable stress of 24 kips per square inch, and we get a elastic section modulus requirement then of 125 cubic inches, from which then you go to your handy dandy design table. In our case, that would be back in Appendix E of your textbook, where you'd find then your C shapes of the channels, and take a look to find the first section or the lightest shape that would be big enough. But Houston, we have a problem. This is SXX of 125 cubic inches. And when you look at the table that we've been provided here, then we find out that our biggest channel that we have is a C15 by 50. And its elastic section modulus for the XX axis is 53.8 cubic inches. That's nowhere close to what we need. So then you're like, well, gee, you didn't give us a very good problem now, did you? Well, maybe that's possible. Or in real life, we sit there and say, okay, I can't use that. I'm going to have to do something different. Now, I could go and I could change the channel to being grade 50, A992, but boy, that would be a real big expense to do. And you might have to wait 6, 7, maybe even a year before the mill would be able to roll that. And that could probably be deadly to your project to have that kind of delay. So you're not going to do that. Instead, what you could consider doing is, well, why don't we just use 2 channels if we're stuck on using channels? And it does happen sometimes that you'll have a contractor that says, look, I don't want to use what you've asked because asked me to use, I've got a whole bunch of these other shapes in stock that were left over from some other project, and I'd like to use them. Can I do that? And you could say, well, okay, let me check that out. Of course, you'll charge them for that, but they'll check that out. And okay, we could stack these channels up back to back, have two of them, and gee, what would happen? Well, you're going to have the same centroidal axis, right? So that means that the geometric property for the eye for this composite section would be equal to twice what it is for the individual. And the distance out to the outer fiber would be the same. So gee, our SXX for that combined would then just be 2 times the 53.8. That seems like a great idea, right? Well, we still have a problem, right? Because 2 times 53.8, that's about 2 times 54, not quite 108. But it's going to be less than what we need, 125 cubic inches. Houston, we still have a problem. We can't do it this way. So, what would we then next do? Well, you're tempted to scream, right, and say, you gave me a bad problem. Or you still think creatively. Perhaps what we could do is we could put a steel plate in the middle, bolt it all together or weld it all together. There's going to be some criteria about how we would do that, but we could put a steel plate in the middle of that so that, because we don't need a lot more SXX here. Again, that's about 108, so we don't need a whole heck of a lot more, but we could potentially do that, right? And that would then end up setting us up for having a situation that would do what we want. We have this 250 kip foot, or maybe, you got to go back to somebody and say, look, I think either I made a calculation mistake or we can't do this out of channels. Right now, the other thing is, of course, in your textbook, you have maybe a limited set of the full things, full available channels. So let's go to a deeper resource, your steel construction manual, and go to your C tab, right? And so I've got all these little tabs here for all these different sections, and we could go and look at and see if there's anything more. I don't think there is. I haven't looked at it recently. So I'll look, and sure enough, when we go look at the channel table, and I'll pull it in real close, right? And you'll see that we still have a C 15 by 50 is the biggest. So the reality is we can't use a single channel here. We can't use 2 channels. We're going to have to still do something else. We're going to have to build up the section, or we're going to have to recommend that we simply go and take a look at a W shape.